Okay, welcome to your last review warm-up. You made it. This is the last one. Okay, so let's go over these questions. Question 1, 2, and 3 are proportional reasoning questions. Okay, and what you're doing is you are looking for the relationship between the numbers. Again, like I said previously, when you're solving these type of questions, you can look at the relationship, but you could also cross multiply and divide. So it's whatever you prefer. In these cases, I am going to look at the relationship because the numbers work so well together. So in example 1, how you have to ask yourself, how do I get from 20 to 4? 4 goes into 20 5 times, so I have to divide by 5. What I need to do then is divide 15 by 5 to solve for the unknown, and the unknown here equals 3. Next, number 2. Again, you're asking yourself, how do I get from 30 to 5? I need to divide by 6 because 30 divided by 6 equals 5. Now 6 divided by 6 equals 1. So that's 5 over 1. Next, how do I get from 3 to 6? Well, you have to multiply by 2. 75 multiplied by 2 gives you 150 kilometers. Okay, so hopefully that was a nice, good review when looking at proportional reasoning. Number 4, calculate 45 3/4% of 800. Now, for this, it's really important that you get rid of this fraction here because it causes a lot of confusion. What I would do is I would turn that into a decimal percent. So 45 3/4 equals 75%. It's still percent, remember that. I think I've stressed that in different reviews. Just because you turn 3/4 into decimal doesn't mean it's now a decimal. It's still a percent, okay? Now, when finding the percent of a number, you must divide by 100 and then multiply by the number, which is 800. When you carry that through, you now have, multiplied here, 0.4575 times by 800, and you get 366 is your answer. Okay, 5. Show this number as a percent and a decimal. Okay, in this hundreds chart, I have 1, 2, 3, 4, 5, 6, 7 full percent, and it's 1 covered a 4, so 7.25%. This can also be represented as 7.25%, but as a decimal, I need to divide by 100, and you get 0.0725 is the answer for the decimal, because I need to divide by 100. Okay, 6. Show 105.3 as a decimal. Okay, sorry, 105.3%. So here, to divide by 100, and what I'm going to do is move the decimal over because it's getting smaller, and you have 1.053 is the decimal. Okay, let's move on to the next one. Okay, for number 7, what I'm going to do is I'm going to first change these into improper fractions. It is really, you really need to know how to do this, and you need to know how to do it kind of like very naturally, okay? You need to be able to go from a mixed number to an improper fraction and vice versa. So let's look at these, and what I'm going to do is I'm going to actually go through 7, 8, and 9, and I am just going to kind of systematically change them into improper fractions. So 7, let's look at this. 1 times 7 is 7, plus 5 gives you 12. 12, and again, here, your denominator doesn't change. It's still 7. Times 2 times 2 is 4, plus 1 is 5, over 2. Okay, let's do this one here. I'll do this one on the bottom. Here you keep that the same. 3 times 4 is 12, plus 1 is 13, over 4. And this one here, 2 times 6 is 12 as well. 12 plus 1 is 13 over 6. And that's times 4 times 3 is 12 plus 1 is 13 over 3. Okay, so now to solve, you're just going to multiply through. Okay, so 12 times 5 equals 60. And now 7 times 2 equals 14. Okay, and now in this case, you can reduce. Okay, and how you can reduce, you could have also reduced here as well. So for example, I know in this case 2 goes into 2 once and 2 goes into 12 6 times. So I could have reduced this beforehand and that would have given me 30 over 7. And then it's easier to sort of put that back. I know that 4 goes into 7 28 times. So that will give me whole number 4 left over 2 over 7. Okay, so either answer is correct there because it didn't ask me to simplify it. In this case here, for 8, 2 times 13 is 26. And that's 12. And that could be reduced to 2 1/6. Next, we have up here, 13 times 13 is 169. 6 times 3 is 18. And you could have reduced that to get 9 7/18. Again, when you're reducing, you're just dividing into the number, finding how many times it goes in completely, and then look at your remainder that's left. That's your new numerator. Your denominator doesn't change. Okay, we're going on to number 10. 10 is, again, a unit. We're looking at unit rates and trying to calculate the better buy. So for number 10, it's asking us to estimate the cost per 100 grams for each jar. In this case, if it costs $5.50 for about 750 grams, you kind of have to think, well, okay, that's kind of 3/4 of 1,000 grams there. And in this case here, it's $1.99 for 250 grams. Again, that's sort of just 1/4 of 1,000 grams. So it's asking you for 100. It's kind of like, okay, if I'm going to estimate, I got to use numbers that like make more sense to estimate for. And so in this case, looking at this 5.5 or 550 for 3/4, it's like, okay, so how much would it cost if I just have 100 of those grams? So in this case, I would just use either $5 or $6 here. So let's say $6. And it's 100. So if you want to look for 100, this is probably like about 7 times more. So you just divide by 7. And for 100 grams, you're looking at about, it's going to be obviously under $1. So about 80 cents. Now here it's $2. This is, you're going to divide by about 2.5. And again, that's about 80 cents. So it's going to be close. Definitely going to be close. So let's just calculate the better buy. When you're calculating, you're dividing. Sorry, when you're calculating for unit rate, you need to divide. So here we have $5.49 divided by 750 grams. And we get a unit rate of 0.00732 per gram. Next, we have $1.99 divided by 250 grams. And you should get 0.00796 per gram. Okay, so I predicted that it was going to be close, and I was right. It is close. This is slightly less money, and therefore it's the better buy. Okay, moving on to question 11. In this question, we need to express the ratio as a fraction, a decimal percent. It's a great question because you really need to be able to go from fraction, decimal percent for your midterm. Okay, so 5 to 40. Let's do a fraction first. So we have here 5 over 40. Now, if I want to go to a decimal, I'm just going to punch in 5 divided by 40, and you should get the decimal of 0.125. Now, to go to a percent, I'm going to multiply by 100. So I'm going to move this over 2 times, and that gives me 12.5%. Okay, let's do the same for 12. 9 over 12 gives you 0.75. Okay, because if you divide both by 3, you get 3 over 4, which is 75, or 0.75. Now I'm going to multiply by 100 to get my percent. Move this over, and that gives you 75%. Okay, great. Let's do the last one here, 14 over 28. And this is half. Like if you reduce this, it's 1/2, right? Which is 0.5. Again, if you're taking a test and you look at this and you don't see 1/2, don't stress out. Take out your calculator, go 14 divided by 28 and see what you get as the decimal. Multiply this by 100, move my decimal over 2 times, put a 0 there, gives me 50%. Okay, and so that's how you go from ratios to finding fractions, decimals, and then percents. Okay, let's go to some problem-solving questions here. Who says math is not important, right? Look at this. You could win a free trip if you solve the skill testing question. Okay, so Jackie answered 6. Does she win the trip? Well, let's perform bed mass here. So I'm just going to look through and circle what I need to do first. Okay, I need to do these things first. Okay, so I'm going to keep this. I'm going to do this. What's 9 divided by 3 is 3. And 6 times 2 is 12. Okay, now I'm going to go from left to right. Please don't forget that. Okay, 1 plus 4 is 5. 5 minus 2 is 3. 3 plus 3 is 6. 6 minus 12 is negative 6. Negative 6 plus 10 equals 4. Poor Jackie. She does not win the trip. See, she should have studied her integers and known bed mass. Okay, question. So here, just to answer, I guess, no, she doesn't win. Sad face. Oh, that's kind of like a mad face. Do sad face. There you go. And a tear. 1 teardrop. Okay, 15. A 90 centimeter plastic figure is 1/20th scale version of a figure that was used in a movie. How many meters tall was the actual figure? This is a proportional reasoning question. So what you need to do is, if this is a plastic figure and the figure, 90 centimeters here, is only 1/20th of the scale version. So basically it's saying that the actual figure is 20 times this scaled version. So essentially what you're doing is multiplying 90 by 20. And you should have gotten 1800 centimeters is the original. It's kind of easy because it's a 1 here. Okay, let's move on to the last problem-solving question. Okay, so this says 2, but it is actually supposed to be 16. Okay. Okay, let's look at this question here. Just need a little bit more space. Memory cards used in digital cameras come in many different rectangular shapes. Your class decides to compare the length of 3 different memory cards. At the end of the experiment, the teams combine their data in the table below. What is the overall average length of the cards? Express your answer in a mixed fraction. So what you need to do is you need to go 5.5. Remember, it's average. So average is adding these all up and then dividing by how many there are, which is 3. So I need to add these together and then divide it all by 3. Now when you're adding mixed fractions, you need to turn them into improper fractions. Okay, it's just kind of what you need to do. And so when I'm doing that, 5 times 2 is 10 plus 1 is 11 over 2 plus 4 times 4 is 16 plus 3 is 19 over 4 plus 8 times 2 is 16 plus 1 is 17 over 2. Now, when I'm adding these together, I need to find a common denominator. And I'm going to use 4 because I can't, 19 is not, like it's a prime number. And so I can't divide 19 by 2. So I can multiply these by 2 and this by 2. And so I'm going to change these. So it's going to now be 22 over 4 plus, this stays the same, plus, and I believe this is 34 over 4. So adding these all together, you should get 75 over 4. Now you got to divide this by 3. You can divide by finding a common denominator or multiply by the reciprocal. I'm going to multiply by the reciprocal. So I have 75 over 4 times, remember this is a number over 1, whole number. So now it's 1 over 3. You should get an answer of 75 over 12, which is reduced to 6 and 1/4. Now, does this answer make sense? Yes. Okay, because if I look at the different length centimeters here, okay, like 6 1/4 is sort of like an average, you could tell, right? Because this one's very big, this one's small, this one's very small, and so it's probably going to be close to this number here, which it is. Okay, next question. The width of each card is 1 1/3 centimeters. The maximum area for cards that meet 2007 specifications is 8 centimeters squared. Do all these cards fit those specifications? Express your answers as a mixed fraction. So you simply here have to multiply the length and the width to find area. Okay, and so you got to do it for each card. So let's look at the first card. Again, because I've already found the mixed number, I'm just going to use the mixed number because I have to do that anyways. And also, what I want to do here is find what the mixed number is for 1 1/3. So 1 times 3 is 3 plus 1 is 4 over 3. So I'm going to be using this number as the width for each. So it's 4 over 3 times, and this card is 11 over 2. It's going to be 4 over 3 times, in this case 19 over 4, and then it's going to be 4 over 3 times 17 over 2. Okay, so let's go through and find the areas for each. In this one, it's 44 over 6. In this one, it's going to be 76 over... Oh, I could reduce, can't I? I should. I'm going to reduce this, actually. Okay, so what I could do here, just to make my life easier, is I can actually reduce this, cancels out, and now I have 19 over 3. I could have done that here too, and I'm going to do it here. 2 goes into 2 once, 2 goes into 4 twice. You got here 2 times 17 is 34 over 3. Okay, now I'm going to reduce. It wants them into mixed fractions. So in this case, you should get 6 goes into 42, 7, and there's a remainder of 2 over 6. Sorry. And in this case, 3 goes into 19. 3 times so 3 times 6 here is 18, and then you have 1/3. Here 3 goes into 34. So let's say 3 times 12 is 36. So it's going to be 11, 33. And there's 1 remainder, 1/3. So it says, do all these cards fit? And of course, I'm forgetting my units here. Okay, this fits, this does not fit. Okay, so only 2 fit. Okay, so that is the end. That was like a lot of fraction stuff going on there. I really like to simplify when I'm multiplying because it just makes the reducing later on a lot more able to handle, or just easier to deal with, I guess. But if that confuses you, again, just multiply numerator, multiply denominator, and then reduce into a mixed fraction. Okay, and that concludes all your warm-up, review warm-ups for your midterm. Hopefully you didn't find that too difficult. Again, if you have any questions, please come and see me for further clarification.